Projectile motion, Chapter 10, Part C, linking the horizontal and vertical motion by using the formula. In the previous session, we know that this complicated projectile motion is 2D problem. You can resolve this 2D problem into two 1D problem. 1D, one of it for horizontal, the other one for the vertical. For the horizontal one, simple one, we can combine the last four equations into two only because A is 0. Ax is 0. No horizontal acceleration or deceleration because we think that there's no air resistance in horizontal and vertical direction. But in vertical direction, we have acceleration due to gravity. Then we can obtain these 6 equations. Now, we try to combine these 6 equations together to find out the unknown variables. What should we do? Of course, you should try to find out all the known values and then choose the correct equation, then you can get it. But before you do everything, you should try to find out the linking, the linker between horizontal and vertical motion. The linker, what is it? Should be the time. Should be the time. Then, very important concept in projectile motion, especially in mathematics, should be the linker, time. And the projectile motion should move in 2D case. 2D means that we have two 1D. They will have the same time, same position for x and y. If you know that the time, you can know that the x position and y position. So time t will be the linker between 1D problem in horizontal and 1D problem in vertical. So here, what links the motion in two directions? Of course, the answer is the time. Time ellipse. So look at this. X link up to time should be this equation, time. This time will also link up the other equation. You can know that the position x and y, you can obtain it if you know that the time. So you can look at this diagram. For unknown x position, if you know that the time, you can get x. If you know that the time in vertical, you also get y. You can get x and y. Then you can get this coordinate at certain time. If you know that all the time, all the position, you can link up them, then you can find out the path, the trajectory of it. Now, try to focus on the example and then know that what is going on. Look at this. Here, you want to aim at the target, but look at this. If there is no gravity, this arrow should move horizontally, a straight line to hit on the target. But in this one, this man will not point to the target. Because we know that we have the gravity, the path should be a curve. Then, if this path can pass through this target, this point, then the arrow can hit the target. Then what should you do? You should notice that the time of flight for the arrow to hit the target. Here, how long does the arrow take to hit the center of the target? The time. How to know that? Before this one, once again, you want to know that the time for the arrow to hit the target. How to hit it? This arrow should move downward 0.2 meter, and then hit it. This one should be governed by the time, governed by the gravity. Then what should you do? This one is the vertical motion, the time of flight. You should pick out the vertical motion equation. We have 4, but this 4 equation, you should link up y. It means that 0.2 meter. You should link up the time. You should link up the gravity, g. Then should be this equation. And also in this case, we think that downward positive. So this part wrong, this part is wrong. Downward positive. outward negative. Then you can see that gravity should be positive, 9.81. Y, going downward, should be positive. And once again, Uy, because you project the arrow horizontally, so initial vertical speed should be 0. After it, you should have 2 woods, but one of the wood is negative. You can reject it. Then you can see that the time for the arrow to move down to have the same level with the target, the time should be 0.202 seconds. And also here, the time for it for the long vertical motion, okay, you can get it 0.202 seconds. Then you should use this time to find out the unknown horizontal motion. It means that you know that the time for this projectile move downward with the same level with the target. At the same time, the path may be like this. Okay, this one can reach the same position 0.2, the same level with the target, but if like that, this case, the arrow cannot hit the target. Or the path may be like this. Okay, also the same level but cannot hit the target. Then what should you do? You should try to find out a certain value just hit the target here. It means that using the same time, this arrow will move downward 0.2 meter. At the same time, this projectile should move forward to this position. If both of them can fulfill it, same Y and same X, then the arrow can hit the target. Okay, so what should you do? Using the same time, you should know that Ux, then we can obtain the range. This range R should be 10. Okay, this time should be the time of flight. This one, you should know it. This one, you also know it. But of course, this one you don't know it in this case because U should be unknown. You can find it out. Then here, we want to find out the initial speed. What should we do? Using this one. The same time of flight for the arrow to travel 10 meters. Then what is your U? Should be 49.5. Once again, you can see that this one, Ux and U are the same. This one should not be true, but in this case, you can find that the projection angle, in this case theta, should be 0. And in horizontal way, you should use the cosine theta. Cosine 0 is 1. Okay, the original formula should be this, but you can notice that theta should be 0. Okay. What if question? If the center of the target is at the same level as the initial position, it means that this one is the arrow. The target should be the same level. Then would the arrow be able to hit exactly at the center by aiming horizontally? Of course, I think that you should know that the answer, no, because we have the gravity. Okay, even if this one aim at the target, but we have the gravity, so path should be a projectile motion. If you want to hit the target with the same level, what should you do? You should have a projection angle to a certain angle, and then the projectile should be like this. Then you can hit the target. Okay. Okay, next one. Example 6. Shoot. This one, football player want to kick the football to the goal. Okay, and here in this question, the height of the goal is 2.44, and this one is 11. The speed given to you, the angle given to you. Then what happened here? And the question tells you that the goal is this height. So that means that prove that 證明 prove that the ball can enter the goal. Pay attention on it. You can see that you know that the angle theta. It means that you should know that the range. Because if you know that you know that theta, you should know that the range. Okay, then here is a trick. We have 2.44 and we have 11. Okay, enter the goal. Enter the goal can do it like this. The trajectory just only touch the maximum height, or just only enter the goal. So in this question, you should test it. If the ball travel horizontally 11 meters, and then check the height of it. This one should be y. Check the height. If this height is higher than 2.44, it means that the ball cannot enter the goal. Lower than it should be okay. Negative value, impossible. Okay, you should try to do it like this. So don't use y is 2.44. Now look at this. The same method. Initially, we solve component. Horizontal one cosine, vertical one sine. And then remember that in this question, T will be the linker 連接點 between vertical and horizontal motion. In this case, you should start it from 11. Because here, we know that we know that the angle, it means that we know that ux. We know that the x, the range, should be 11. Then you can calculate the time for the ball to travel in mid-air. Then using this time t to link up with the vertical displacement to check what is the vertical displacement. Put it into this equation. Once again, upward positive. Okay, so the acceleration should be negative. After your calculation, you should be 2.313. It means that if the ball travel 11 meters, the position of the ball should be here, 2.313. It means that it can enter the goal. Okay, you should use this method to check it. Okay. How about next? Find the velocity of the ball when it enters the goal. It means that this, once again, you should pay attention. This v should be in kind of 傾斜, because this one should have two components. One is the horizontal, the other one should be vertical. Then you should calculate what's the horizontal. Horizontal, of course, you should know that should be ux. It means that 14 times cosine 30 degree. How about vy? This one I should say that vx is ux, okay? How about vy? You should calculate. Of course, using the formula, vx should be ux, this one. How about vy? Vy should be u plus at. Pay attention, a should be negative. After calculation should be negative, of course. Okay, a negative. If vy is negative, it means that this, the final velocity you should be lower than the horizontal one. 衝緊向下面. Okay, 1.9. Then combine them together using the Pythagorean theorem. Then you can get the final speed. Okay, at the same time, using the tangent theta, you can get the angle. This. Okay. Okay, part D, projectile motion and conservation of energy. In the last one, we should use A, V, U, A, T, S, like that. Okay? But now, this one, we want to focus on the energy. For example, potential energy and kinetic energy, like that. Okay? Now, what will happen for it? Look at this. If air resistance is negligible, okay, it can negate it, then the total energy should be related to the GPE and kinetic energy. So look at this. At the starting point, usually will be on the ground. GPE, you can let it 0. Okay, this one should be the initial KE. When the projectile go to the mid-air, it will have the velocity at the same time. Mid-air usually should be higher than the initial point, mgh, and this h should be y. Okay, then what can you see? You can see this graph. This one is the time. For time t is 0, then the energy should be this. Okay, and also when it go to the mid-air, for example this time, then you can see that mgy plus kinetic energy. Add them together, should be conservation of energy, should be the same. Okay, and how about this purple line, purple curve, should be PE. For the time higher than the initial point, PE should be larger one. Then it means that this part should be kinetic energy. Up to this part, also kinetic energy. You can see that in this part, the kinetic energy should be the smallest value, okay, the minimum value. But why? Because this one, you can see that the projectile should move horizontally only. This value is ux, vx only. How about vy? In this case should be 0. Momentarily advance in vertical direction. Okay. How about ke? Similarly, this one, the highest point. Okay. Then what will we do in this part? If the question public examination given to you, you can see that here should be the kinetic energy for this. If you can find out this value from the graph, this value, it means that this value should be equal to half m u x or vx square. Okay, with from the graph, then this energy, you know it. Usually the question gives you m, then using the graph you can find out vx and ux, and also at the same time you can find out the maximum height. You can get many information from the graph. Okay, here at highest point, ke should not be 0, should be half m ux square. Then you can read it from the graph and then calculate. And also from the highest point, mgh should be highest point. You also can get where is the highest point. To find the speed of the projectile v at a certain instant, in the last example, you can see that you can use the Pythagorean theorem, find out the vx, it means the ux, and also the uy. Combine them together, Pythagorean theorem, you can find it out. But of course, if you're using the energy, very easy part, you know that the initial one, final one, plus the certain height, mgh. Then after the calculation, you can find out v. Look at this diagram. The question gives you u and theta. Ask you, where is it? Y. Okay, measure from the reference point. Then using this equation, only one equation, then you can find out v. Okay, this one seems to be simpler than this. Of course, if you find out this, you cannot obtain the angle phi, because in here angle phi simply be not. But of course not, because if you know that v, you know that vx, then you can find out this angle phi using the cosine phi, then you can find it out. Okay, so here only initial speed and height y are necessary, then that's all. Okay, look it again. Example 7. Similarly, shoot again. Find the speed of the ball when it enters the goal. Using the energy approach, initial ke, initial pe is equal to sum of the final ke and pe, conservation of energy. Initial one should be half mu square. Initial GPE, we net is 0. Okay, and also in this question you should find out what's y should be 2.31. okay, u should be 14, then after calculation should be 12.3. okay, simpler than the last solution. Here if he kicked the ball at a larger angle with the same speed, how will be the speed of the ball when it enters the height 2.31? Still this one, because you can go back to this equation. You can find that theta is not important. Okay, you haven't used any theta, so if you change it the theta, but final y is the same. Okay, then you may ask that why we can have the other angle, because in the last part you know that theta will have the same range, and also we have the other theta to have the other same range should be 90 minus theta. So this angle may be like that. It will go up and then go down like that. This angle should be 90 minus theta. Okay. Okay, next one. Example 8. In this one, focus on different paths P and Q, using the same projection speed but difference in projection angle. Here, which one lands with the higher speed? Okay, of course, here we have two approaches. The first approach is just only hit the ground. You can focus on ux, it means that vx, and vy. This one also. Okay, you can do it using the perfect theorem, but of course in this part D, we will using the energy approach. Try to focus on it. Now, same u, it means that same initial speed, same kinetic energy initially, and also they start from the same position. It means that the total energy, initial total energy should be the same. How about the final velocity? You can see that both of them will drop down here. It means that GPE loss in the same amount. Okay, same vertical distance, same amount of GPE. Then we will have the same change in kinetic energy. So this one proves that they will have the final speed will be the same. Okay. And what if question? If air resistance cannot be negated, which ball will land with higher speed? If we have air resistance, it means that longer path, the effect will be greater. You can see that P will be longer path than Q. Then the effect of air resistance will be greater than path Q. Okay, so here, the effect acting on path Q will be less than that in P. It means that energy loss should be less than it. Higher speed will be for path Q. Okay, next one. Monkey and hunter. We revisit again. You can see that initially, in this top projectile motion, initially, we aim at the monkey. If this monkey will not move, the bullet cannot hit it. Okay, but when this monkey suddenly very afraid with the gun and then free fall, then it will hit it. Okay, the bullet will hit the monkey. Okay, like that. Okay, because in this case they will have the same vertical displacement for the bullet and the monkey. If the time is just enough, okay, same time, same horizontal distance, and same vertical displacement, then the bullet can hit the monkey. Okay, last one, Ch10.2. Here we have the water, a jet of water project horizontally, okay, 1 meter from the sea level. Then where does the water enter the pool? Okay, take the watts. In this case, I think that you should take downward positive, okay, and forward, or it means that the right hand side as positive. Then we solve the component. Once again, this one is project horizontally. It means that only horizontal component. Ux should be 3, Uy should be 0. And also, how about the time of flight? Once again, for the time of flight, focus on the vertical part. Vertical displacement should be 1. Because you take downward positive, then this one should be positive 1. Gravity 9.81 should also be positive. Then apply this formula. Y is positive 1, Uy is 0, Ay should be 9.81. Substitute it, negative words will be rejected, only positive 1. Then this one, time of flight. Time for the water to reach the sea level should be 0.4515 seconds. Next, range. Once again, for the range, you should focus on the horizontal one, but time of flight is important. Is R Ux times T. Ux should be 3. Time of flight should be the last answer. Then you can get it, the range. Okay, second question. The projectile is projected horizontally at a certain angle. Which of the following graphs best show how is Ke changed with the time t? Okay, look at this. Project horizontally at a certain speed, and then find out what will happen. Look at this. Because we have the gravity, as time is going on, then what will happen? This. Okay, kinetic energy will be increased and increased. But how to prove it? Look at this. We project it horizontally for a certain angle height y, okay, and then this one u. Initial speed will be half mu square. This one is the initial kinetic energy, so we can negate it. Ke, initial Ke. And this one, when this one drop down, then you can see that we will have the change in GPE. Ke should be increased. Then you can see that as time is going on, all the Ke should be increased. But pay attention. The initial one we have U, it means that we have the initial Ke. This initial Ke is not 0. Should be greater than 0. So option A and option B should be incorrect because starting from origin. So this one tells us that should be starting from this. And then afterwards should be this. How about the time t related to kinetic energy? Okay, is it a straight line? You should try to investigate it. Now look at this. You can see that Ke should be increased. But why? Because we have GPE decrease. But what is GPE? GPE should be mgh. It means that S. And once again, S and T, what is the relationship? You should find out that this one plus half AT square. Okay, square. You can see that the vertical displacement should be related to time square. Square, it means that quadratic should be a curve. Then, should be like this. And once again, you can see that Ke should be related to speed. You can see that under free falling. Like that, you can see that the velocity should be increasing. Okay, increasing, but not linear increasing, should be quadratic increasing. So this one explains it why this one is a curve. Okay, this one is the explanation. A horizontal one, vertical one is AT. But here you can know that this part should be time square. Okay, time square. Okay, that's all.